established the quotient rule for solving our function. Then we are given this series of functions or questions. Then we have to find their derivative. That means that if you look at this function, there are two different functions that depend on s and they are dividing themselves. So we have to use quotient rule. Quotient rule again is going to be the y ds is v du ds minus u dv dx all over v squared. So solving the second example 2, we have y equals 5 exponential x all over cos x. So we have my u to be 5 exponential x, then my v is cos x. So we need our du dx. Differentiating this with respect to x, that's still going to give us 5 exponential x. Because we told ourselves about differentiation of exponentials, we are not going to go in depth in this, but this is just a constant. So constant doesn't have a function of s, so we just write down on back. So the v, the x is going to be minus sine x. So the y, the s, which is going to be applying the quotient rule, is going to be u dv ds. My u is 5 exponential s, the v ds is minus sine s. Oops, sorry, that's supposed to be v du dx. It's not u v du ds. I'm using quotient to not product rule. V du dx, and that's 5 exponential s. V du ds minus u. My u is 5 exponential s minus u dv dx. That's minus sine s all over v squared. And my v is what? Cos squared s, or cos s squared. So this is going to be, I want to just factorize the numerator. 5 exponential x is common. This is cos s plus sine s. Right here. So we have cos squared s. I'm looking at any manipulation that can be done to this. Of course, we have trigonometric identity that will give us this. Cos squared s plus sine squared s is equal to 1. I can add this as 1 minus sine squared s, but that's what use is not necessary here. So we just leave our answer like this. So the y dx is equal to this, and that's our final answer. And finally to the third question. Y is equal to tan s. If you are convenient with your geometry, you know that this one is sine s over cos x. That's the first thing. So that means we are going to be applying the quotient rule. So my u is sine s, my v is cos s. The u dx is cos s, the v dx is minus sine s. The y dx is v du dx, that's cos s. The u is also cos s minus u, which is sine s, minus u dv dx, that's minus sine s, all over v squared, which is cos square s. And that's cos square s plus sine square s, that's cos square s. Cos square s plus sine square s, according to trigonometric identity, is going to be 1 over cos square s. 1 over cos square s is 1 over cos. The inverse of cos is sec. The inverse of cos, 1 over cos, 1 over cos. 1 over cos s is sec s. So this implies that 1 over cos square s is going to be equal to sec square x. So when you differentiate, the derivative of tan s is sec square s. That's where we got it. So I think this gives us the final question that we can encounter as a basic question on differentiation using our quotient rule. Then we move to some other aspect, which is function of the function rule, or we call it the chain rule. Stay with us.